Hello again, students. Today we're going to work with the number of elements that we have in each of our sets. So we're going to start off with a review problem from last time. All right, so the easiest times that you can find the number of elements in sets is when you have partitioned. If you're working with a partitioned universal set. Remember, the word partitioned means that each of the individual subsets, when you look at them in pairs, they're called pairwise disjoint, which means that there's no overlap. All right, and then to be partitioned, not only is there no overlap between any of your subsets, but the union of them all, so when you add them all together, they equal your universal set. All right, so this problem, it says a set X with the number of elements in X is equal to 100 is partitioned into subsets A, B, C, D, and E. Find the number of elements in subset D if the following information is true. All right, so the number of elements in B is equal to 3 times the number of elements in A. That notation, okay, isn't bad, but I'm going to simplify it just a little bit. I'm going to use a lowercase b is equal to 3 times A. So what I did here was I just replaced the number of elements in set B with a lowercase b to make it look more like a variable that you're used to working with. All right, so the number of elements in set C is equal to 4 times the number of elements in set A. The number of elements in set E is equal to the number of elements in set B plus the number of elements in set C. And the number of elements in set D is equal to the number of elements in E minus 10. All right, so we have set A, B, C, D, and E. And technically, they're all subsets of the universal set, but that's 5 unknown values. So think back to your algebra days. If you have 5 variables, that means that you need to have 5 equations. And what I'm looking at right now is only 4 equations. So right here, the word partitioned. Remember, the union, so that means everything in A, everything in B, everything in C. Union means that they're connected with the word or. Okay, and what we're going to do is we're going to add. Their union is 100. So here is another equation that we can write. We can write A plus B plus C plus D plus E is equal to 100. All right, so this looks just perfect for substitution. All right, because we have A already, but B, I could replace it in terms of A. So I still have A, but I could replace B with 3A. I could replace C with 4A. I could replace D with, well, this one's not in terms of A yet. However, E we know is B plus C, but B is 3A and C is 4A. So E is 7A. So over here we could write this as D equals 7A minus 10. All right, so we could replace D with 7A minus 10 plus E, which is 7A, equals 100. All right, so combine like terms, so A plus 3A plus 4A, that would make 8A plus 7A, that's 15A, plus 7 more would make 22A, minus 10 equals 100. That would give us 22A is equal to 110. So divide both sides by 22 and we get A is equal to 5. All right, so we can plug those in and get all of the number of elements in our subsets. This said find the number of elements in subset D. So here's D. D is equal to 7 times A minus 10. So this is equal to 35 minus 10. So that means that there are 25 elements in set D. All right, so like I said, that one shouldn't be too bad finding the number of elements because we were talking about a partitioned universal set, which meant that there wasn't any overlap. Now, that's hardly ever going to be the case. You're a lot of the times going to have overlap between your sets. All right, so with this second example, we're going to let F represent the set of all students in Finite. We're going to let S represent the set of all seniors, and we're going to let U represent all of the students at RCHS. All right, so we're going to represent this as a Venn diagram. So I'm going to draw a box. That's my universal set. And then there are 2 subsets. We have F, the number of students in Finite, and we have S for just your seniors. All right, so looking up some school data on Harmony, I found that the number of students in RCHS right now is at 686. The number of students in Finite this year, there are 17 students. And the number of seniors, according to Harmony, is 149. All right, so where are we going to place these numbers in the Venn diagram? Well, everything needs to total to 686. All right, the number of finite students is 17, so that means that all of circle F should add to 17, and the number of seniors, all of this circle should add to 149. Okay, however, we have seniors that are in finite, and this year we actually have every student that is taking finite as a senior. So we're going to place everybody, and this isn't always the case. Sometimes I have juniors, but we are going to place all 17 people that are in this finite class in the overlap because you guys are also seniors, which means that we don't have anybody that's just taking finite that isn't a senior. And the number in S then isn't going to just be 149. The total is 149, but in this portion right here, it means only seniors, but not in finite. So if we subtract that overlap, if we subtract that 17, we're going to come up with 132. All right, so now we need to figure out how many students are there that aren't taking finite or aren't seniors. Well, this year, since there aren't any students that are just taking finite that aren't seniors, makes it pretty easy. All we need to do is take 686, the number of students at RCHS, minus the number of seniors, and that's going to give us how many students that we have that are not seniors, nor are they taking finite. All right, so now that we've placed all of or we've figured out all of the number of elements in each of these parts of our Venn diagram, now what I want to do is I want to make sure that we're comfortable with distinguishing which part of a Venn diagram we're talking about based off of the symbols. So this takes some practice. All right, and so sometimes you might have to draw more than one Venn diagram in order to be able to know the region that they're talking about. And that's okay. It's going to take some getting used to. When I say S and F, that means the intersection of S and F. All right, so let's let this be F and let's let this be S. The overlap is right here. So this is your portion S and F. S and not F. All right, so complement of F. So that means everything that's in S that is not an F. So everything that's in S that's not an F, that's this right here. So this is S and not F. This is everything that's in F and not an S. This is going to be your not an S and F. And then the last one, S or F, means everything in the circles, but then we're taking not, so that means everything outside. So this is S or F. Notice the parentheses make a very big deal here. Okay, if those parentheses weren't there, it wouldn't mean the same thing. Using words to describe your scenarios. In this scenario, the set S not would best be described as students at RCHS that are not seniors. S not and F. S not and F, if you need to, you can come over here to the Venn diagram. S not and F, that's right here. That would be your students taking finite that are not seniors. So some years I have that, some years I don't. This is a year that I don't. S not or F. So the only thing I changed was or. So that means they could be students that are not seniors or students taking finite. All right. The union rule. Well, we'll look at it a little bit today. We'll look at it more next time. The union rule is saying, so here's union. The number of elements that you have in set A or B is equal to, let's go back up and look at our example here. If we take the number of elements in our first set plus the number of elements in our second set and then subtract the overlap, we can't have it count twice. So that's going to be the number of elements in set A plus the number of elements in set B. But since that overlap would be in both of these, we'd have to get rid of it one time. So then it only counts once. All right, so this is going to be a very important formula that you need to memorize. All right, there is an extension for it if we were to work with 3 sets. Okay, but we're mainly going to focus on using this formula only for 2 sets. And if we have 3 sets, then we're probably going to go to our graphic. We're going to go to a Venn diagram. All right, so now let's go ahead and do some examples. We may or may not be using that union rule. All right, so a survey of 75 college students was taken to determine where they got the news. So we know that there are 75 total college students that were surveyed for this. Of those surveyed, 29 got their news from newspapers. So we need to label one of these circles, one of these sets represents newspapers, and the other one represents television. 29 students got their news from newspapers. But if I put 29 right here, that means that they only get it from newspapers. If I put 29 right here, it means that they get it from newspapers and television. So most likely, I'm going to need to split up 29 and have a portion of it out here and a portion of it in here. So as you're working with Venn diagrams, the key is to work innermost first. So the innermost part, anytime that you have any intersection. So the goal is to put a number here first. And if you can't put a number, you put a variable. So if you keep reading, it says 7 from both newspaper and television. So that means a 7 goes here. Remember, all of circle N, all of set N is 29. So that means that this portion is going to be 29 minus 7, which would give us 22. Then all of set T is 43, but we already said 7 of those 43 also get theirs from newspapers. So 43 minus 7, this would give us 36. All right, and then last but not least, okay, it's not drawn in here, but normally you have a rectangle outside of your sets because we could have people that don't get their news from newspapers or televisions. Okay, internet, that's probably a big one now. Honestly, that's usually where I get mine. All right, so we need to take into account that 75 total students were surveyed. How many have we accounted for so far? So if we take 22 plus 36, that's up to 58, plus 7 more, that's up to 65, but we had 75 students, which means that 10 students didn't get their news from either newspapers or from television. All right, we're going to make it a little bit more challenging. Now we're going to go to 3 sets, and you can read through this problem if you need to, pause it. All right, but just like up above, the key with working with Venn diagrams and placing your values is you want to work innermost first. So this right here is going to be the overlap of students that said that they partook in drinking alcohol, smoking cigarettes, and using illegal drugs. So this would be the overlap. Writing that out, that would be A and C and D. All right, the intersection of all 3. So 97 engaged in all 3 behaviors. So I'm going to put a 97 right here. 309 engaged in none of these behaviors. So that means outside in just the universal set, but not in any of the subsets, there are going to be 309. All right, then once you did the innermost, now you're working your way until you're to the out. All right, so we're still going to work on the inner part, but this is now going to represent right here. This is going to represent, so this part right here, A and D. All right, so A and D. Let me get rid of that part right there that I just drew. A and D, so alcohol and drugs. 114 people drank alcohol and used illegal drugs. So all of this makes 114. We already know 97 of them did all three. So the remainder, the ones that only did both alcohol and drugs, but not all three, would be 114 minus 97, which is 17. It might be helpful to cross out some of these numbers. 119 smoked cigarettes and used illegal drugs. So cigarettes, illegal drugs, these two should make 119. So we already know this is 97, so 119 minus 97 would give us the 22 right here. 424 drank alcohol and smoked cigarettes. So these need to add up to 424, but we already placed 97, so 424 minus 97 would give us 327. 192 used illegal drugs. So all of this circle D represents 192. We've already placed a portion of that. So 192 minus 17 minus 97 minus 22 is 56. You can do your math off to the side if necessary. All of circle A is 894. So 894 minus 327 minus 97 minus 17 is 453. And 665 for all of circle C. So 665 minus 327 minus 97 minus 22 is 219. All right, this final example for today gives us our three sets, and it gives us this information, but it doesn't give us any background. Okay, so you're going to have to, again, recognize symbols and what they mean. So this one right here is going to represent the innermost, the intersection of all three sets. So let me go ahead, A, B, and C. The intersection of all three, so the innermost piece is 5. Okay, now you're going to work your way on the intersection of just two sets. So the intersection of B and C, so B and C, this is 12, but we already have 5 here, so 12 minus 5 would give us 7. All right, so I use this one, I use this one. The intersection of A and B is 18, but again, we already used 5 here, so this would be 13. Uh-oh, they didn't give me the intersection of A and C. So if they don't give you a value and you need to work with it, okay, you're going to use a variable. So this is going to be x. All of circle A is 50, but we have already placed 3 values. One's a variable and 2 are actual numbers. So what this is going to be, the part that's only in A, is going to be all of A minus what we already have. So 50 minus the 13 and 5 would be 50 minus 18, which is going to leave us with 32, and then also subtract the x. All of circle B is 40, but we already know these. Okay, 13, 5 makes 18, 7, this makes 25. So 40 minus 25, this would give us 15. All of circle 3 adds to 35. Not 3, circle C adds to 35. This portion, 12 or 5 and 7 makes 12. So 35 minus 12 is going to give us 32. And then you also have to subtract the portion that we don't know, which is x. This last part is the only other piece of information that we have not used yet. The number in A or B or C. So thinking about that, here's A, here's B, here's C. Drawing this or shading it in, here's all of circle A. Here's all of circle B. Here's all of circle C. So union means we get to keep all of our shading. We're not looking for the overlap, we get to keep it all. So that means that everywhere where we just placed either a number or a variable, that's what this is describing. And this is saying that they add up to 85. So now we get to make a big equation. We get to say 85 is equal to the sum of all of these. Now, I'm going to make it a little bit easier for you. Okay, notice that all of circle B, we already have value for. So all of circle B, so I'm going to shade it. Remember, all of circle B was 40. So I'm going to go ahead and put 40 right here. All right, and then now we just have to have, I said 23 and I wrote 32. I'm sorry, I just now realized my mistake. All right, so now, okay, all of B, now we just have to account for these 3 other pieces. So this is going to be plus 32 minus x. This is going to be plus x, and this is going to be plus 23 minus x. All right, so simplifying before we start moving from one side to the other. Negative x plus x cancels out. We still have a minus x. And then 32 and 23 makes 55 plus 40 would make 95 minus x. All right, so moving 95 over would give us negative 10 equals negative x. So 10 is equal to x. All right, so this piece right here would be 10. That means that 32 minus 10 would give us 22, and 23 minus 10, this would be 13. So the key with this is to make sure, unless you know that they're partitioned, that's where it's really nice, there's no overlap. If once you know that there's going to be overlap, start with the innermost first. So start with that overlap and then work your way out.